Lesson 3.7 is on simplifying algebraic expressions. If you look on page 162, before we get started, we're going to talk about the definition of simplify. So some of the problems they're going to ask you to simplify something means that we have no like terms and no parentheses. So anytime if you're working a problem, if there are parentheses in it, we're going to be distributing. If there's any like terms, we are going to be combining those like terms together. So if you look at example 1, we talked about this a little bit in the previous lesson, but they're talking about here terms that have the same variable part, like y and 2y, are called like terms. Also, we've talked about if you have just plain numbers like 5 and 3, those would also be like terms. And the deal is with like terms that those can be combined together. So like I said, simplifying means we are going to work the problem out to where we end up with having no parentheses and no like terms. So if you look right below here, they are wanting us to write simplified equivalent expressions for these two expressions. So the first one, we have x plus x plus x. Anytime you have a variable, if there's not a number in front of it, if there's not a coefficient, you can always put a 1 there, because kind of the idea is instead of x, if I have 1x, that means 1 times x. If you multiply something by 1, doesn't change it. So we can put 1s in front of all these x's. We've got 1x plus 1x plus 1x. Those are like terms because the variable is the same. So we combine those together, that would be equal to 3x. So x plus x plus x is equivalent to 3x. Notice in that final answer, this is simplified because there are no like terms and there are no parentheses. If you look at the other example, they wanted us to combine 2y minus y. Once again, the y, we can put a 1 in front of that. And then 2y minus 1y would just be 1y, or you can just rewrite that as y if you want. It's kind of the same idea. 2 minus 1 is 1. 2y minus 1y would be 1y. 2 times something minus 1 times something is the same as 1 times something. So if you look at the try it, they want us to simplify this expression. So the first thing I'm going to do is I'm going to put 1s in front of the z's. And then I'm going to try to combine some terms together. If you'll notice, all of these terms have z's, so these are all like terms. We can combine all of them together. So if you look, first of all, what the book did here is they are just putting 1s in front of the z's. If there's not a z there, these two don't have numbers in front of them, so they're just putting 1s in front of those. Usually when I write my z's, I write a line through it so it doesn't look like a 2. I don't write my 2's like that, but some people do, so just to avoid confusion, especially if you write your 2's like this. And then at this point, you don't have to do this step if you don't want to, but the book's just saying it's kind of like they're factoring out all the numbers in front of the variables. Again, you don't really need to do this by my consideration, but then basically we're just working our way across here. So 4z minus 1z would be 3z, and then 3z plus 1z would be 4z, and 4z minus 2z would be 2z. So our final answer is 2z. If that's too much for you to keep track of as you go through to work the problem out, you can just work out one part at a time. So you could say like 4z minus 1z is 3z, and then just bring the rest down. 3z plus 1z is 4z, and then 4z minus 2z is 2z. The convince me talks about how do we know that the expression 2x plus 4y is not equivalent to 6xy. And what we can do on this problem is just look at your terms. We've got a 2x and we've got a 4y. And those have different variables. They have different letters. And so if they have different variables, they are not like terms, so we can't combine them together. So this is actually already simplified. There's nothing more we could do with that. We're going to look at some problems on page 164, and then we'll go back to some of the other examples in the book. So on 164, if you look at number 6, they want us to simplify this expression. As you're going through, if you're watching this video, you can pause and try to work the problem out and then watch the explanation would probably be a good idea. So for number 6, we can put ones in front of all these terms. 1 times something doesn't change it, multiplying by 1. So then we can combine, since these all have x's, these are like terms, we can combine them all together. So 1x plus 1x plus 1x plus 1x would be 4x. So 4x would be our simplified expression. Number 7, similar idea. We can put a 1 in front of this y. We've got 4y minus 1y, which would be 3y. Number 8, we do have some like terms, but they're not all like terms, so we're going to just make sure we just combine the like terms together. And when you do this, the like terms, the sign to the left goes with the term. So we want to look at this. We've got 2 like terms here that have y's. We have a 7y minus 6y. So 7y minus 6y would be 1y. And then the minus 4.5, make sure you don't lose that sign to the left of it. Minus 4.5 just comes down. Technically 1y is the same as y, so if you just wrote it as y minus 4.5, that would be okay also. Number 9, similar idea. We've got 2 terms that have x's on them, so those are like terms. So 4x minus a half x. 4 minus 1/2 would be 3.5, so that would be 3.5x plus 2. If we go to number 10, on 10 we've got a constant, just a plain number here. We've got another constant, so we can combine those together. So 3 minus 1 is 2. And then we also have like terms with y's. The second one, we can put a 1 in front of it. So 3y plus 1y would be 4y. So we could have 2 plus 4y. The commutative property, you can change the order since they're adding. If you wanted to, you could write that as 4y plus 2. Either of those would be correct. Number 11, again, we can put a 1 in front of the x. So we've got 1x plus 6x would be 7x. Number 12, we can combine these terms together. They both have w's. So 5/10 plus 1 7/10, if you want to work that off to the side. Make sure your decimals are lined up when you add or subtract decimals. And that would be 2 2/10. So 2 2/10 w minus 5/10. And again, make sure in your final answer you don't have any parentheses and you don't have any like terms still left. So this gives you a little bit of an idea of how to simplify algebraic expressions, and there will be 2 more videos in this lesson to help you learn some more about this. Have a good day.